if this box represents all the variables that we deal with when it comes to thermodynamic systems, we can classify them into two parts. First is called as extensive and another is called as intensive. This is extensive. Now, what is a benchmark which helps us decide on this? So what is that question which takes care of the division? So basically, yeah, what is that question that leads to such classification? The question is, okay, so the question is, do the variable depend on size of the system? So if the answer is yes, it becomes extensive. If the answer is no, it becomes intensive. Okay, so let me go through the slides. Let us see a few examples and we'll understand this. So understanding how state variables behave when the size of the system changes is what we're looking at. The state variables describe the equilibrium state of the system. So the variables that we are dealing with is your pressure, volume, temperature, and so on and so forth. Mass, density, quite a few things. So we basically classify it as extensive and intensive. Extensive deals with how much, intensive deals with how intense. That's why the word intensive. So size dependency. So the thermodynamic variables are divided into fundamental characteristics based on the behavior with system size. So extensive depends on the size, yes. When the system is divided into two equal parts, it becomes half. While intensive, it does not depend on the size. Even if you divide to any number of parts or expand it as well, it will remain the same. Again, the same idea being enforced. So official definition, extensive variables are those whose magnitude is proportional to the size of the amount of the system. Key test is the system, if the system is split into two equal parts, each part have half the value. If it's so, then we are looking at it to be an extensive variable. For example, volume. If I cut the volume, it will become half, right? If I divide a system into two equal parts, the volume will be reduced. Of course, mass also will be reduced, number of moles will be reduced, while internal energy also will be reduced because we are cutting the system into two equal parts. Entropy, enthalpy, all of this is an extra bit, but yeah, all this comes under extensive. While at the other end, you have intensive. Intensive variables are those variables that are independent of the system size. For example, even if we cut into two equal parts, temperature doesn't change. If you have a system which is at equilibrium, if I cut it into two equal parts, will the temperature change? Example, if you have a kettle, you have hot water in that. If I pour water into my cup, the temperature will not change. The volume changes. Volume in the container reduces, but the temperature will not change. Pressure will not change. Density will not change. Concentration will not change. Chemical property, specific heat capacity, all of this will not change. Now, that you guys have studied. Honestly, I know that you guys have studied all of this. So why is that we are repeating? There's an important result that we need to be very clear with. Golden rule and key takeaway. So let me explain it this way. See, if I happen to multiply an intensive with an extensive, my result will be extensive. For example, pressure, it's intensive. While if I multiply with volume, change in volume, this will give me work. So this is extensive and this is also extensive. If I divide an extensive by an extensive, for example, U by N, that's what we have it on the slide, you will end up with an intensive result. So this will give us intensive. Okay. So let me give the example over here. U by N, the internal energy per unit mole is an intensive property. It's like per kg, you know. So if you're dealing with per kg scenario, it is intensive, right? So intensive properties deal with that. So this is the second important result. First and the third one. Then whenever you have to equate, right? You have to equate extensive, extensive, and extensive. Okay, so this is your equation consistency. So your equation has to be consistent. It has to be extensive, extensive, plus or minus extensive. So this is one more thing that you have to remember. 3 results that you need to keep in mind that helps. So the golden rule when it comes to intensive and extensive is multiplying intensive with an extensive will give you extensive. Extensive by extensive will give you intensive. And you can always add extensive with extensive giving an extensive as a result. So extensive, here you have an intensive times of extensive scenario. So this results in extensive. So this entire thing is extensive is equal to extensive. Okay, so if you guys want to write this flowchart, you can. If not, yeah, this is good enough. It's the same message. If you guys want to write anything from here, the golden rule, that slide has to be written. All of this is left to you.